Okay, grade 12s, what I want to do is I want to continue with the proportionality theorem, but what I want to do is I want to look at the concept of ratios. Now, this is something that's very important. What I'm going to say to you is if you look at this whole length is going to be 21 centimeters. Okay, so the whole length of AB is 21 centimeters. Okay. But what I'm going to say to you is if you look at this point C, C is going to divide AB in the ratio of 4 to 3. Now, I want you to watch this carefully. We're going to say AC to CB is 4 to 3. Now, if you look at this carefully, this is going to give you 4, okay, and that is going to give you 3. But I've got a problem with that because if you think about it carefully, 4 plus 3 is 7. It's not 21. So what does this mean? If you notice that if you look at the line segment AB, it's divided into 1, 2, 3, 4 for AC and 1, 2, 3. It's into 7 parts. So we can refer to the 4 as parts. Okay, you've divided up the line AB into 7 equal little parts. And from A to C is 4 parts, and C to B is, of course, the 3 parts. But now the question is, what would a part be? What would the size of a part be? It can't be, you can't say that that's 4 centimeters there. So I'm not sure what these parts are. They equal in size or in length, but what would they be? So let's call them K. And you probably agree with me that you've got 4 of those Ks, so 4K plus the 3Ks would of course give you 7K. And we don't know. We actually going to be very interested in finding out what the length of each, what little part is there. What is the length of that thing? We don't know, so we're calling it K. Alright, now, if you think about it carefully, this is 7K. Alright, but the 7K, all of those actually add up to 21 centimeters. Okay, so what you really have, if you think about it carefully, you've got the 4Ks plus the 3Ks is 21 centimeters there, which means that 7K is equal to 21 centimeters, which is true, these are like terms. Divide both sides by 7, and K is equal to 3 centimeters. Now, what does this mean if you think about it? Well, each part, if I just bring that up there, each part is 3 centimeters. Now, look at that. If that's 3 centimeters, all of those, so what is 4 times 3 is 12. And there you've got 3, each of those are 3, so 3 times 3 is 9. So look at that, that's 21 if you add up those. 12 and 9 is 21. And then but that is actually 4 parts to 3. And look at this carefully. If you take 12 centimeters and you divide by 9, you actually get 4 over 3. Look at that. That's the ratio in simplified form. If you divide both by 3, you see that there. So this 4 over 3 represents the parts, the division into parts. But we have to put a K there and then work it out. Worked out what that K is, which happens to be 3 here, to be able to determine the actual length of AC and the actual length of CB. You see that there? Okay. And that 4 over 3 is what we call the ratio of AC to CB. But the actual length of AC is 12 and the length of CB is 9. Okay. Alright, have you got it there? So let's look at an example where we use this concept. Okay, and how it's going to work is I'm going to give you a little triangle, and this triangle is DEF here. Okay, and what I'm going to say to you is that, okay, these lines are parallel, which is great. I'm going to say to you DE is 32 millimeters. Okay, let's work in millimeters. And DF is going to equal 24 millimeters. But I'm going to give you a ratio. I'm going to say to you DG to GE is equal to 5 to 3. In other words, DG to GE is a ratio of 5 to 3. But remember, that's got to do with the parts. Okay, so what we need to do in this case is I need to indicate something. So I'm going to put a K onto those because it's 5 times something. We don't know what it is. So you always indicate that. And remember, the length of DE is also 32 millimeters. That's the full length. Now, obviously, if this is 24, you can clearly see that there's no ways that DE is equal to EF in length. But remember, from the proportionality theorem, the ratio of DG to GE is DH to HF. So this is also 5, and that's also 3. But remember, this is just broken up into 1, 2, 3, 4, 5 parts, and 1, 2, 3. So we must indicate it by something else. We must say 5p and 3p there, if you like, because that would be the actual length there. If you remember with ratios, if we go back and have a look at this, you might have 4 parts, but we indicate that as 4k for the actual length. And the 4k, if you look at 4k, is 4 times 3, which is 12 centimeters. Each k is the actual size there of that little piece. So whenever you do ratio calculations, like in this example, when the ratio is 5 to 3, you put a K onto each of those to work with the actual length, you see. And likewise, the ratio is 5 to 3 on the side because the lines are parallel, but you must put a P there or some other letter different to K, but it's exactly the same. So we always do that. All right, now, how would we then, and the question I want to ask you is, how do you get the length, the actual physical length of all of these sides? So you wanted the length of DG, GE, you want the length of DH and HF, DH and HF. This is the lengths you want to find. Now what you could do, if you think about it carefully, if we take on the line DE, if we add up the 5K and the 3K, we get 32. So we've got 5K plus 3K is equal to 32 millimeters, which of course is 8K is 32 millimeters. Divide both sides by 8, and K is equal to 4 millimeters. That would be the actual length of K, you see. But now, what would DG be if you think about it carefully? Well, DG is actually 5K. If you think about it, DG is 5K. So what would its actual length be? If you think about it, would be 5 multiplied by the 4 millimeters, which is 20 millimeters there. Okay, so that's great. So this is 20 millimeters. 5 times the 4 for K. Alright, what about this? Well, if that's 32, you can clearly see that that's going to be 12 millimeters to make up the 32. But what is 3 times the 4? If K is 4, is 12. So look at that. We can say that GE, if you think about it, GE is 3K, which is 3 times the 4 millimeters, which is 12 millimeters, which is exactly true. And likewise, if you look at this, what do we know about this? Well, 5p plus 3p is 24. So let's work out that. 5p plus the 3p is 24 millimeters, which of course gives you 8. P is 24 millimeters. So P is equal to 3 millimeters there. So if you look at that, the actual P is worth 3 there, 3 millimeters, although it's 5 parts to 3 parts there. Okay, so let's have a look at this. What would DH be? DH is 5P. So let's have a look at this. DH is equal to 5P, which is 5 times what is P? Is 3 millimeters, which of course is 15. Now look at that. If DH is 15, okay, that's 15 millimeters there. Remember the P, what was the P? The P worked out to be 3. So what you're dealing with here is 5 times 3. What's 3 times 3? Is 9 millimeters for HF. And what's 15 plus 9? Is 24. So remember, whenever you deal with ratios, if they give you a ratio, what you immediately know is that you've got a 5 parts to 3 parts. So you put a K on there, and then you add that up. 5K plus 3K is 8K is equal to 32. So that's what we did there. 8k is 32, so k is equal to 4. So once you know what k is 4, then you can say 5 times 4 is 20, 3 times 4 is 12. And look at that, 20 plus 12 is 32. And likewise, 8p is 24, so p is equal to 3 millimeters. 5 times 3 is 15, and 3 times 3 is 9, giving you the 24. And there we go. And remember too, the reason why I could jump from there to there is simply because of the fact that GH is parallel to EF there, you can see.